Hello all, have a nice time. Today our topic of discussion is harmonic functions. So what do you mean by a harmonic function? A function f of xy, which is a function of two variables x and y, is said to be harmonic if it satisfies the differential equation fxx plus fyy equal to 0. Fxx means as it is dou square f by dou x square plus dou square f by dou y square equal to 0. We have to differentiate f with respect to x twice, differentiate y f with respect to y twice, then adding. So if this expression equal to 0, we say that the function f is harmonic, or if f satisfies this differential equation, we say that f is harmonic. And this particular differential equation is what is called Laplace equation. And the theory says that if f of z equal to u of xy plus I v of xy is analytic in a domain D, then it has continuous second partial derivatives in D, and both u and v satisfy the Laplace equation. U satisfies Laplace equation means that uxx plus uyy equal to 0. V satisfies the Laplace equation, so we have vxx plus vyy equal to 0. The expression uxx plus uyy is denoted in this way, and it is called nabla squared, or you can call it as del square. So del square u or nabla squared u equal to uxx plus uyy, that's equal to 0 since u satisfy the Laplace equation. And if two harmonic functions u and v satisfy CR equations, Cauchy-Riemann equations, that is ux equal to vy and uy equal to minus vx in a domain D, they are real and imaginary parts of an analytic function f in D that we have already discussed in the last class. Then v is said to be a harmonic conjugate function of u in D. That is, if you have two functions u and v which satisfy the Cauchy-Riemann equations in a domain D, then they are the real and imaginary parts of an analytic function f in D. So if you know two functions u and v which satisfy CR equations, and also they are harmonic, that is uxx plus uyy equal to 0 and vxx plus vyy equal to 0, then if you write an expression like this, u plus iv, it becomes an analytic function. And we call v as the harmonic conjugate function of u in D. Now, today our topic of discussion is how to find a harmonic conjugate function by the Cauchy-Riemann equations. So first problem is verify that u equal to x square minus y square minus y is harmonic in the whole complex plane, and find a harmonic conjugate function v of u. That is, we have to find the function v such that u plus iv is analytic. So it is given that u is equal to x square minus y square minus y. So we have to find v. So here you can find ux and uy. What is ux? Ux is 2x, because when you find the partial derivative with respect to x, y is treated as a constant. So it is 2x. And uy equal to, then x square is a constant, minus y square derivative is 2y, minus 2y, minus 1. So ux equal to 2x and uy equal to minus 2y, minus 1. By Cauchy-Riemann equations, we can say that vy is equal to ux. This is equal to 2x. Also, you have vx is equal to minus uy, that's equal to 2y plus 1. Uy is minus 2y minus 1, therefore minus uy is 2y plus 1. So from these observations, we have to find the function v. Okay. So consider this one as equation 1. And this one as equation 2. Okay. So in equation 1, what we get is the derivative of v with respect to y is 2x. So how can we find v? V is, we have to integrate the function vy with respect to y. Because here we are getting the derivative of y with respect to, so derivative of v with respect to y. So to find v, we have to integrate v with respect to y. So you have integral 2x dy. So this is equal to, now when you integrate, you have to consider this x as a constant, because we are considering the integral with respect to y. So 2x is a constant and integral of 1 with respect to y is y. So you have 2xy plus a constant. But when you write the constant, you have to remember that here you are considered x as a constant. Okay. So you have to write this as a function of x. When you find the derivative of the right hand side, what happens? We are finding the derivative with respect to y. So here derivative of y is 1, so 2x. So with the 2x, then h of x derivative with respect to y is 0. So what happens is the derivative of this expression is 2x itself. So when you integrate 2x with respect to y, we are considering x as a constant. So the integration constant of integration becomes a function of x. Okay. So here what we get is x, but what we get is v, but we have to find the function of x here, h of x here. So what we do is, we will find Vx. Actually, we know Vx equal to 2y plus 1. But we will find Vx using this expression. What's the derivative of V with respect to x? From here, derivative of V with respect to x is 2y plus derivative of x becomes 1. Okay. H of x derivative is h dash x. Now what happens is, from this expression 2, you get Vx as 2y plus 1. Here what we get is Vx is equal to 2y plus h dash x. So comparing these two equations, you can write this h dash x is equal to 1. Okay, so what will be h of x? Derivative of h is equal to 1. Therefore, h of x is integral of 1 dx. So this is equal to x plus a constant c. So now you can write v is equal to 2xy plus h of x is equal to x plus c. So you have 2xy plus x plus c. So this is the harmonic conjugate function of u in the domain. And you can see that if you write the function f is equal to u plus iv, that is u is equal to x square minus y square minus y plus I into v is 2xy plus x plus c. If you construct such a function, you can see that this function is analytic. You may verify that this is analytic. Now we will do the problem 16. Okay, the question is, are the following functions harmonic? If your answer is yes, find a corresponding analytic function f of z is equal to u plus iv. That is, if there is u is given, we have to find the harmonic conjugate of u, if u is analytic. Okay, sorry, if u is harmonic. So the 16th question is, u is equal to sine x into cos hy. Okay, so first you have to verify whether the u is harmonic or not. So you'll find the first derivative with respect to x, ux. Sin x derivative is cos x into cos hy, because you have to treat cos hy as a constant. Now uy is equal to sin x into cos hy derivative is sin hy. Okay, now you have to find uxx and uyy. Uxx is cos x derivative is minus sin x into cos hy, and uyy is sin x into sin hy derivative is cos hy. So you can see that uxx plus uyy equal to 0. So you will conclude that uxx plus uyy equal to 0. Therefore, the function u is a harmonic function. Now, since u is harmonic, you can find the harmonic conjugate of u. So, how will you find the harmonic conjugate? Here you have already found ux and uy. So, the harmonic conjugate is v, and you have to find vx and vy. Vx is equal to minus uy. By Cauchy-Riemann equations, vx is minus uy. So, this is equal to minus sin x into sin hy. Okay, and what is Vy? Vy equal to Ux. Ux is cos x into cos hy. From these two equations, we have to find V. So from equation 1, we will find V first, and V is equal to, in equation 1, it is given that Vx equal to. Okay, so to find V, we have to integrate the expression with respect to, we have to integrate this Vx with respect to x. Okay, so you have integral Vx is minus sin x into sin hy dx. So here some minus sin hy may be taken out. It is a constant, it is treating as a constant. So minus sin hy into sin x integral is minus cos x. So it becomes a plus cos x plus the constant. So here instead of the constant c, you have to write it as a function of x. Because you are, a function of y, because you are treating y as a constant here. Okay. Now, from the second expression, you have to make use of the second expression to find this h of y. For that, we will find the derivative of v with respect to y, because the second expression is vy. So, we will find vy using the expression what we have already found. Vy means that we have to find the derivative of this expression with respect to y. Sin hy, derivative is cos hy. So cos hy into cos x is a constant because you are finding the derivative with respect to y. Okay, plus h of y derivative is h dash y. Now this is the third expression. So what happens? From 2 you have vy equal to cos x into cos hy. From 3 you have vy is equal to cos x into cos hy plus h dash y. Now comparing 2 and 3, you can find h dash y. What is h dash y? This is equal to 0. Okay, comparing 2 and 3, you can find that this h dash y equal to 0. H dash y equal to 0 means that h of y is integral of this expression 0 dy and it is equal to a constant. Okay, so now you are in a position to write v. What will be v? V is equal to sin hy into cos x plus the constant c. So this is a harmonic conjugate of u. And now you are in a position to write f of z. F of z is, you just write u plus iv. U is already given in the question, sin x cos hy. And v is here, it is sin hy into cos x. So u plus iv becomes the analytic function. Let us do one more question of the same type. U is given as e raised to x sin 2y. So first of all, you will find ux. Ux is e raised to x derivative is e raised to x itself, e raised to x into sin 2y. And uy equal to e raised to x into sin 2y. Derivative is 2 cos 2y. Okay. Now you will find uxx. Derivative of this one with respect to x again. So e raised to x into sin 2y itself. And what is uyy? That's equal to 2 into e raised to x into minus 2 sin 2y. So you have altogether minus 4 e raised to x sin 2y. Now you can see that here uxx into uxx plus uyy is not equal to 0. So you can conclude that here u is not a harmonic function. Now another type of question, determine a and b so that given function is harmonic and find a harmonic conjugate. Okay, so let us do the problem 21. Okay, if you use v itself, then you have to write the formula accordingly. Then u equal to e raised to pi x into cos ay. First we have to show that, or you have to find this a so that this function is harmonic. If this function is harmonic, you know uxx plus uyy equal to 0. Here ux equal to, we are differentiating this function with respect to x. You have pi e raised to pi x into cos ay. Uxx equal to, again, pi square e raised to pi x into cos ay. Actually, here it is pi, not a. Okay, then uy is, we are differentiating this with respect to y. So how e raised to pi x into cos ay, derivative is minus a sin ay. So uyy is, similarly you can find this uyy as minus a square e raised to pi x cos ay. And if u is a harmonic function, then uxx plus uyy equal to 0. So you can conclude that pi square e raised to pi x cos ay minus a square e raised to pi x into cos ay equal to 0. If this equal to 0, then the function u is harmonic. And here you may take e raised to pi x into cos ay as a common factor, and you can conclude that this equation equal to 0 if pi square is equal to a square, or a is equal to plus or minus pi. So if a is equal to pi or minus pi, then this function u is harmonic. So let us take a is equal to pi, and you may write u is equal to e raised to pi x into cos pi y. If you take minus y also, minus pi, then also you can see that if you substitute this a is equal to minus pi, then cos minus pi y is equal to cos pi y itself. So here u is equal to e raised to pi x into cos pi y. Now you have to find the harmonic conjugate of this function. So here we have already written ux and uy there. Just substitute a is equal to pi. So from here, ux is equal to pi e raised to pi x into cos pi y, and from here uy equal to minus a, that is minus pi e raised to pi x into sine pi y. Okay, so by Cauchy-Riemann equations, we know ux is equal to vy and uy equal to minus vx. So we start with any one of these equations. I take this as a first equation, then this as a second equation. In the first equation, it is given that derivative of y with respect to y is this function. To find y, you have to differentiate this expression with respect to y. So what we do is v is equal to, we have to integrate with respect to y. So integral pi e raised to pi x into cos pi y. With respect to y, we are integrating, so dy. So this is equal to, when you integrate with respect to y, pi e raised to pi x is a constant. So cos pi y integral is sine pi y divided by pi. Plus a constant you have to write, and we will write the constant as a function of x, because we are considering x as a constant here when you integrate this expression. So here pi cancels and the answer becomes e raised to pi x into sine pi y plus a function of x. So this is our answer. But in this answer, you have to find what is the c of x. Okay. For that, we are making use of this second equation. Here you know what is vx, minus vx you already know. So we will find vx from this expression. From here, we may write vx equal to, differentiating this with respect to x. So we have pi e raised to pi x into sine pi y plus the derivative of this expression, c of x derivative c dash x. Okay. Now this is equation 3. Now compare equation 2 and 3. Here minus vx is this expression. So vx is pi e raised to pi x sine pi y. Here vx is pi e raised to pi x sine pi y plus a function. So from comparing 2 and 3, you can conclude that this c dash x must be equal to 0. Then only these two are equal. 2 and 3 are equal. Okay. So c dash x equal to 0 means that c of x equal to integral of 0 dx, that is a constant. Okay. Because when you find the derivative of c, it becomes 0. Okay. So you can conclude that from star, you can conclude that the harmonic conjugate v is equal to e raised to pi x sine pi y plus the constant c. Okay. So this is a harmonic conjugate of the given function.